So, hi everyone. Today I'm going to talk about tokens making a spacewalk. I'm going to talk about tokens that make a spacewalk from one blockchain to another blockchain. I'm talking about bridges. Spacewalk is a unified bridge concept for Polkadot, and it's a very modern and secure approach because it's decentralized, it's trust minimized, and it's censorship resistant. And these three aspects are very important for us because there have been a lot of attacks on bridges in the last couple of months, and a lot of money has been lost. So Spacewalk is going to improve that. Hello, I'm Torsten, I'm the CTO of Pendulum. And Pendulum is the project behind Spacewalk. So let me first talk about Pendulum. Pendulum is a parachain project for Polkadot. As a refresher for you guys, Polkadot is a network of blockchains themselves. And those blockchains in the Polkadot network are called parachains. The advantage to be a parachain on Polkadot is that Polkadot gives you a lot of security by Polkadot itself. And there is a shared consensus model. And furthermore, you have bridges between all those parachains that allow you to move tokens between parachains and also to move messages. All those parachains on Polkadot have a special purpose. Our mission of Pendulum is to connect fiat networks with the DeFi ecosystem. What that means is that we are specializing for stablecoins in Polkadot. And to be more precise or more specific is that we are tailored for Forex. So we built the perfect or ideal Forex ecosystem for debt developers. Another USP is that we are tailored for businesses. That means that if you're a business and you want to build and you have a special business need, for example compliance, then Pendulum is also the perfect blockchain to build your application on. For example, if you want to make a cross-border payment from a business to a business, B2B, that would be such a use case. Another aspect of Pendulum is that we're optimized for Forex. Just a second. 5 minutes left? Okay. I saw the sign, sorry. Another aspect of Pendulum is that we have local banking integrations in many different countries. And what that means is what I'm going to show you on this next slide. So this is an example of a cross-border payment. And as you see, Pendulum is right in the middle of this example. And inside Pendulum, you have this Forex AMM. This is an AMM that's optimized for Forex. And that means that you have optimized curves, price curves for Forex, and single-sided liquidity pools, and it's based on historical data. You actually don't have just one of those Forex AMMs, but you have a whole ecosystem. As I said, Pendulum is tailored for Forex. And if you now look at a B2B cross-border payment, then you would look at a payment from a region A with a fiat currency in region A, and you want to move this to region B. And for that, you use these local fintech or banking integrations in region A and region B to tokenize the fiat currency of region A and to detokenize the fiat currency of region B. And then you would just exchange those fiat tokens inside Pendulum using the Forex AMM. So as you see here, those local banking integrations are very important for Pendulum, but it's not enough. We also need to build and want to build bridges to all those other blockchains that have great support for stablecoins. And that would be, for example, Stellar, Celo, or Solana. And that means that we are going to build or already building a lot of these bridges. And we actually bring in those stablecoins into the whole Polkadot ecosystem through Pendulum. As I already said, once they are in one parachain, those tokens can be easily moved around the other parachains, for example, Akala or Astar, and can be usable by them. So we looked at many different bridges and many different blockchains and studied how to build those bridges. And it becomes apparent that many different bridges require many different technologies to be built. So there is really a diverse approach to bridges. And this is very complicated. And this is where Spacewalk comes in. Spacewalk is a unified approach of those bridges for Polkadot. So it's a bridge standard for building those bridges. And it's not just a standard, but it's actually a real bridge implementation. So there's a repository for Spacewalk that implements this standard. And as I already said, Pendulum is one of those parachains that uses Spacewalk, but it's not limited to Pendulum. It's actually an independent project. It's a community project. It's supported by a Web3 grant, by a Web3 foundation, and can be used by all the other parachains in Polkadot. And what it actually means is that Spacewalk boils down to a pallet. And so I need to explain what a pallet is. Most projects in Polkadot are built using a technology called Substrate. Substrate is a framework for building blockchains. It's very powerful, it's very flexible, and the flexibility comes through those reusable components that are called pallets. So pallets are components that you can plug into your own Substrate project, and they give certain features to the project. For example, a pallet for smart contracts, for EVM smart contracts, or for WebAssembly smart contracts. A pallet for multi-signatures. And, for example, a pallet for bridges, as Spacewalk. And Spacewalk is not just a pallet, but it's also a combination of services that you need to run in addition to your blockchain. For example, oracles or custodian clients. It very much depends on what kind of blockchain you want to bridge to. I want to stress again that Spacewalk is decentralized. We studied many different bridges, and it becomes apparent that a lot of bridges that are out there are not really decentralized. They're either totally centralized or they claim to be decentralized but are actually not. And a lot of money has been lost because of this. Spacewalk is also trust minimized. What that means is if you have to deal with a human actor, that human actor is always incentivized to not misbehave. And if they misbehave, you are guaranteed to get your money back. Another aspect, again, is that Spacewalk is censorship resistant. So if you have to deal again with human actors and they deny service to you, you can always go to another human actor or custodian, or you can become your own human actor. You can become your own client in the decentralized network of Spacewalk, so that at the end you're always guaranteed to get service. Let me show you what it means to use Spacewalk for your own Substrate project. Spacewalk is a unified approach. It has a unified API, it has unified components. If you plug in Spacewalk to your own blockchain, then you have different components that you can use to build bridges to different blockchains, for example, Stellar or Solana. And what that unified approach means is that, for example, you have unified mappings. That's one aspect I want to explain. When I say mapping, I mean that you have certain features of blockchains that need to map into other blockchains. And those features are, for example, how assets are represented. Some blockchains represent assets as ERC20 contracts, like Ethereum. On Bitcoin, you have BTC. On Substrate, you usually don't have smart contracts to represent assets, but you have pallets themselves. So you have many different approaches how to represent assets, and that needs to be mapped. And Spacewalk is going to unify this. Another big aspect is how you represent amounts or balances. You might have 64-bit numbers, you might have 128-bit numbers in different blockchains. Units are represented differently. Also, that needs to be mapped. Spacewalk is going to do that. Thirdly, Spacewalk is also going to map address spaces. In different blockchains, address spaces look very different. You have, for example, Ethereum-like addresses. In Substrate, you have different addresses. On Bitcoin, you have different addresses. All of that needs to be mapped. Spacewalk is unified, is buying this. And when I talk about addresses, I also need to talk about key pairs and signatures, because every user usually has a key pair in a blockchain. The public key is used to derive the address. And this key pair also determines what kind of signature scheme you use. You have different ways to sign your transactions in different blockchains. Also, this is going to be standardized with Spacewalk and unified. Now, this is a lot of theory. I want to change to a real example. Let's have some fun and let's look at the Stellar example of Spacewalk. So Stellar is a blockchain, and Spacewalk is also building a block to Stellar, or is also building a bridge to Stellar. And I'm going to talk about Stellar because Stellar has great capabilities or great features when it comes to stablecoins. Stellar invested heavily into building, into having local banking integration with many different banks over the world to tokenize fiat currency. So they have fiat-backed stable coins in many different countries, for example, Brazilian reais or Nigerian nairas. And that's quite a number of these fiat-backed assets. And these are real compliant and real stable coins. I have to say stable coins because now we know that there's also a group of stable coins that are not so stable, algorithmic stable tokens. So Stellar did definitely a better job, and those stable coins are really very stable. I also want to talk about Stellar for a different aspect, not just because it has those great stablecoins, but because it's very challenging to build a bridge to Stellar. Why is it challenging? First, Stellar doesn't have smart contracts. If you build a bridge to a smart contract chain, then that's still complicated, but it's easy to do in a trustless way, because you can implement your bridge logic as a smart contract. Everyone can study that smart contract and can become convinced that the bridge behaves as it's supposed to behave, and you don't need any trust into the smart contract. If you don't have smart contracts, you need human actors to replace those smart contracts, and you need to trust them. That's a problem. Another big problem is that Stellar doesn't allow for chain relays. Chain relays are typical components of bridges in other networks. For example, if you build a bridge to a proof of work chain like Bitcoin, you would use a chain relay. A chain relay is a system that allows your bridge to see what happens in the other blockchain. And this system is based on two different features of a proof of work chain. First, that a proof of work chain uses Nakamoto Consensus. Nakamoto Consensus means that if you know all the blocks in the blockchain, or more precisely only the block headers, then using those block headers you can arrange them in sequence. And that's actually not just a sequence, but it branches out. But you will always know what the currently valid block is, or the currently valid subsequence, by just looking at the weight that is inside the block header. If you only have those block headers, you don't know yet what transactions are inside the block, but everyone is able to prove in a very efficient way that a certain transaction is inside the block. And this is based on Merkle proofs. Merkle proofs are based on the fact that transactions inside a block are usually arranged as a Merkle tree. This is what you see there. And if you want to prove that a certain transaction is part of that tree, you go to the chain relay and you just present the path of your transaction, which is a node in that tree, the path to the top of that, to the root of that tree, and the path is usually quite short. So logarithmically short. That means that if the block has, let's say, 1,000 transactions, then the path only has 10 nodes and it's very short. And because of these very short and efficient proofs, you can have a really scalable chain. You want to process a lot of transactions in a bridge, and for that reason everything needs to be small and efficient. And this is called simple payment verification, and it's usually possible for chain relays. None of this is possible with Stellar, because Stellar doesn't use Nakamoto Consensus, and Stellar doesn't arrange their own transaction in the Merkle tree. So we had to work around this, and it makes it much more challenging. I'm going to present to you what we did, but first I want to talk about the basic aspects of such a Stellar bridge, how it works. The Stellar bridge knows two different main operations called issue and redeem, and they are just moving coins first from Stellar to the substrate chain or to Polkadot and back. Let's first look at that issue operation where someone wants to move a token from Stellar to Polkadot. And what they do is that they first send their token inside Stellar to a special account, and this is called the locking account. That locking account locks that token and makes it unusable for a certain amount of time. At the same time, our Spacewalk pallet, that component of the substrate chain, has a lot of power and is able to mint tokens inside the substrate chain and can send it to the user account on the substrate chain. And by that, we create actually a wrap token on the substrate chain, a wrap token that's backed by that lock token on the Stellar side. The opposite operation is redeem if you want to send that wrap token back. Again, very simple. The user instructs the Spacewalk pallet to burn a token inside substrate, then it's gone, and at the same time the locking account unlocks that token and sends it back to the user. This whole scheme works quite well as long as the locking account behaves as expected and doesn't send tokens somewhere else or uses tokens for their own purposes. And the problem, or why that could happen, is because Stellar doesn't have smart contracts, and for that reason there are human actors that control that locking accounts. And you need to trust that human actor or those human actors. One basic approach to mitigate that trust problem is that you don't just use one account owner, but a group of account owners, something we call Decentralized Authority. And that's something you can easily implement in Stellar, because Stellar knows this system of multi-signature accounts. That means that you can have multiple users that own an account together, this locking account, and they together have to sign transactions. Or usually have something like an N out of M account. That means that a subset of those users need to sign a transaction. And for that reason, you can accept that a certain number of those users are actually not trustworthy and are actually attackers. This whole system has a lot of limitations. First, in Stellar you can only have 20, at most 20 co-signers, and that's not really decentralized in my opinion, because once you have 20 co-signers, not a new signer cannot just freely join that network. And decentralization means that there should always be someone who could join a network or leave a network. So this 20 co-signer limit is a true limitation. Another problem is that you need your own protocol to coordinate signing and change of signers. So whenever a new signer wants to come in or a signer leaves, then you need a protocol, they need to communicate with each other, and they need to somehow arrange that the locking account now has a new number of signers. Quite complicated, and you want to avoid that. The worst problem though is that this system is prone to Sybil attacks. That means that a single malicious actor could take over a number of those signers, unbeknown to the public, and could then control this. For example, that actually happened in March. There was an attack on a bridge, and that used precisely the schema of 5 out of 9 signers. So there were 9 signers for this login account. 5 had to sign a transaction, and a single malicious actor was able to take over 5 of those actors, 5 of those signers, and was able to steal $600 million. That's a real big problem. And quite obvious that this is not really a trustless and a decentralized system. So we had to come up with something better. And now I'm going to explain what we did. And this concept is actually based on InterBTC. InterBTC is another bridge that exists between Bitcoin and Polkadot. And InterBTC is based on peer-reviewed academic work, has been in development for quite a number of years, and is very secure and really trustless and decentralized. And we employed that concept for Stellar. The main aspect of InterBTC, of that approach, is that you introduce vaults. What you do is that you don't have one locking account, but that you introduce a number of locking accounts. Actually, a total dynamic system of locking accounts or vaults. Everyone can come in and create their own vault, and everyone can just leave that system. So it's really truly decentralized and dynamic. Every vault has their own operator. It's again a human actor. It can also be a group of human actors that operate that vault. That doesn't even matter. What matters is that you have this set of vaults. So what we see is that we actually have decentralization not by owners, but by the number of vaults and locking accounts here. Still, this is not really secure because those vault operators could misbehave. And the next step to control those vault operators and to ensure that they don't misbehave is to introduce collateral. So you have collateralization, actually you have over-collateralization. What that means is that before the vault operator can use their vault and can add their vault to the network, they first need to lock collateral with the Spacewalk pallet on the substrate chain. And you usually use the native token of Polkadot, which is called DOT, or Kusama, which is a similar chain. They need to use that. It's a very stable token, has a lot of value, so there is a lot of wealth behind that. They need to lock that token in the Spacewalk wallet before they can operate their vault. And Spacewalk pallet will ensure that the value of that collateral always is at 150% of the value of the locked tokens in the vault. Let me give an example. Someone wants to transfer USDC, a very famous stable tokens, and locks them in the vault, and the vault operator locks DOT tokens in the collateral. So you have 2 different tokens here, and their value can change all the time. That's kind of a problem because originally it was supposed to be 150% of the token value, but if it changes, it can actually drop so that the collateral is not worth as much as the locked tokens anymore. So what actually happens if the collateral value gets too low, then the Spacewalk pallet will liquidate that vault. Liquidation just means that it's now open for arbitrageurs. Arbitrageurs can come in, can take the collateral, can exchange it, and can give back the originally locked USDC to the user, so that the user will definitely get their money back in case this event happens. The third aspect is that we introduce a Stellar Oracle. This is the component that replaces that chain relay that I talked about at the beginning. The Stellar Oracle ensures that the Spacewalk palette knows about what happens in the Stellar network. And that's required in two instances. First, if someone wants to issue tokens, meaning sending tokens from Stellar to Substrate, then the Spacewalk palette needs to know about that because it needs to mint tokens. The other instance is that the Spacewalk palette needs to know about a situation where a vault operator misbehaves and takes the lock tokens for their own purposes and moves them somewhere else. And in both cases, the Stellar Oracle is used to convey that information. Now let me show you how that Stellar Oracle works. It can only touch upon the very superficial level. I cannot really go into details. But what it does is that it's based on how consensus works in the Stellar network. And this oracle is as secure as the Stellar network consensus algorithm itself. The Stellar has a very special consensus algorithm, which is based on the fact that every node operator in Stellar expresses what other nodes they trust. And through the system, there are Stellar nodes that enjoy more trust than other nodes. If you take all the nodes that enjoy the most trust in the Stellar network, so to say the most respected nodes, then this group of nodes is called the Tier 1 network. And it's enough to look at that Tier 1 network to see what the Stellar network votes on and what blocks are finalized. Now the nodes in the Tier 1 network, they send messages around whenever they vote. Those messages are signed. Every node has a key pair. And by reading those signed messages, you can convince about what actually happened when those nodes voted on a block. So what the Stellar Oracle does is that it takes the signed messages about the voting of the Tier 1 network, and that's very limited, it's only 23 nodes, and sends them over to the Spacewalk palette. And then the Spacewalk palette is 100% guaranteed to know precisely what those nodes voted on and what the whole Stellar network voted on. There are many more details to the system, but all of this is encoded in the Spacewalk palette, and whenever this setup of Tier 1 validator nodes changes, we can use a governance mechanism to also re-encode the information in the Spacewalk palette. And that works very securely. Now that's all I wanted to talk about when it comes to Spacewalk. I hope that you enjoyed that talk. I also hope that you start to look into this. If you want to know more about this, go to this link. We're also very happy if you follow us on Twitter, or even more happy if you get involved in our project. Go to this repository and just start to interact with us, open issue, or work on this project together with us, or even include it on your own chain. Thanks a lot. I think there's no time for questions left. I don't know. Do we?
Okay, you're the last one.
Yeah. So if anyone has a question, then please go ahead.
What if
Here.
Stellar Oracle gets compromised?
It cannot get compromised. So it's okay. Of course, it's actors that can be compromised, but it's built in a way that there needs to be at least one single node in that Oracle network that works well, and that's enough. It's not that there is a 51% attack. It's not possible. There just needs to be one node that you can trust, and then it works in a guaranteed way. And the point of, and the reason for that is that it only conveys signed messages. And the Spacewalk palette knows precisely what the public keys of the Tier 1 validator nodes are. That this even works efficiently is because there are only 23 Tier 1 validator nodes. So if you had to look at the whole Stellar network, it would not be possible. But that's an aspect of the Stellar network itself. And we know quite a lot about this because we also operate 3 of those Tier 1 validator nodes. We have been doing this for 4 years already, so we know quite a lot about that. But it works very securely. And if this can be compromised, then also the whole consensus algorithm of Stellar itself could be compromised. So that's why I said it's as secure as Stellar. Yeah?
Is then this solution very specifically tied to Stellar itself?
This one that I presented here is very much tied to Stellar because Stellar has a very special consensus algorithm. Spacewalk itself is more general, but I just wanted to talk about this special aspect. And I basically picked the most complicated Spacewalk instance so far. The other ones, depending on what blockchain you're talking about, are more simple and can use bridges that already exist. But there is no real Stellar bridge in existence yet that is really decentralized. So it's the first one. Sorry, here?
Yeah,
Here.
I just wanted to,
Okay.
to basically pull up. So basically Spacewalk is a parachain. Is a
Exactly.
I have like a parachain, I can install this as a pallet, like do this, basically enable it with governance control mechanism. Now I can choose to have a plugin either to Stellar or to Cell or something on that you show before. So there is no specific consensus that is like required on top of what I have as a parachain in comparison to the relay network. It's just a pallet, and each node in my parachain has this pallet, and then I need a plugin for particular, like let's say, cellular network, and that's it.
That's it. Yeah. But you have to still run some services that are dependent on the blockchain that you want to connect to. Like you need certain oracles. As I said, we need an oracle for stablecoins. We need a price feed oracle for the Stellar because otherwise we cannot control whether the collateral still has the right value compared to the stablecoins. For other blockchains, for example, you would not need this price feed oracle. So that's very dependent on what kind of blockchain you connect to.
Yeah, but you kind of still get the info from the outside.
Yes.
Let's say each node in my parachain knows about this. So they kind of going through the agreement with the on-chain info within the parachain.
Yes.
Okay.
Yeah. Exactly. So for the Stellar bridge is something that we are currently working on. For the other bridges, some of them we work on, some of them are still part of this concept that we defined. We'll publish that soon, how that concept works. So it's at first, that's what I said, it's a standard, but it's also an implementation, but the implementation is not, we are not having all the implementations yet. We can only do so much, and it's still a young project. So we just recently got the Web3 grant for this from the Web3 Foundation, which is very important in the Polkadot network, of course. So it's a project that's not so mature yet, but it will be later this year when our Pendulum network goes live at the latest. There's a question there at the end.
Yeah, I just wanted to ask, how do you manage refunds for users if your bridge operator is compromised?
Yeah, so I talked about this liquidation. I did not go into a lot of details. I said that this concept is based on InterBTC, and the text specification of InterBTC is a document that's 210 pages long or so. And 120, I think it was 120. I don't want to exaggerate, but it's still quite a lot, and there's a lot of peer-reviewed work behind that. So the liquidation process opens up. The liquidation happens when the collateral has 120% of the value of the locked tokens. So there's still a big gap, which is interesting for arbitrageurs. They come in, they take what's in the collateral, they will exchange that at exchanges and exchange it into the original stablecoin that's locked on Stellar side and give it back to the users.
My question was about more like who decides if that's being compromised?
Oh, that's the Spacewalk palette. The Spacewalk palette has a lot of logic for this, but it needs to get outside information. So there are watchers that feed the Spacewalk palette with information that some of the vaults misbehaved. And this happens through the Stellar Oracle. The Stellar Oracle is can provide enough information about the fact that some of the vault operators misbehaved. For example, the Spacewalk palette can see that the vault operator sent some of the locked funds that should be locked, sent them actually somewhere, although there was no redeem operation right then. So it's only allowed to move funds to another account in Stellar when there was a redeem operation. So if there was really some tokens burned on Stellar side. Otherwise, the Spacewalk palette can see that something malicious has been going on. But it's very unlikely that this will happen in the first place because the vault operator will definitely lose. They will always lose more than they get from misusing those tokens because their collateral will be stashed. The person behind you?
Yeah, so I wanted to ask about the incentives for running a vault. So, because you need to put a lot of collateral, so this is a cost for you. So
Exactly. That's a very typical problem with these over-collateralized systems. So InterBTC is already live. As I said, we are not live on mainnet yet, but InterBTC is live already for 2 months, I think, and they put a lot of research also into that aspect because obviously the first approach was just to use transaction fees and give them to the vault operators. And that's a big question whether that would be enough. It very much depends on how heavily the bridge is used. So you cannot tell upfront whether it's enough. The worst case would be that some person just moves a really high value of tokens once to the substrate chain or to Polkadot, and then the bridge is not used for any other purpose. Then you would use those lock tokens, the collateral tokens. This is very unlikely that this extreme scenario happens, but there are two other approaches to solve that. One is that you would use liquid staking, and that you would allow to use liquid staking tokens as collateral. That's actually what InterBTC does, and that improves the situation heavily. So that you can still use your tokens and stake them with other projects that or protocols that give you a high return. Another one is that you could also actually have some inflation, introduce some inflation in your chain. If you want that, of course it has its own downside, and then give some higher value to the vault operators that are more than just the fees.
I see, thanks.
Any other questions? So thanks a lot for your questions, and have a great day then.